welcome to this lecture, the GCF, the greatest common factor. That's what our learning target is, to be able to factor out the GCF of polynomials. So let's see how this works. A good hint to do factoring out GCF when you're trying to factor polynomials, if there's more than one variable, so like in this example there's x and y, probably a good bet all you can do is factor out a GCF. Now that's just sometimes, not all of the time. But factoring out the GCF, here's what you ask yourself. What does each term have in common? And then what's left when I take that away from each term? So let's just take it thing by thing. If the numbers 3, 12, and 6, what's the greatest number that would divide all three of those? It's actually a 3. Now I've got x cubed, so I've got 3 x's here, a single x in the middle term, and x squared in the last term. Okay? So how many x's could I take away from everybody? Well, just 1, because the guy in the middle only had 1 to give up. Now can I take away any y's? No, because the first and last don't have any. So then what would be left when I divide by a 3 and take an x away? Well, there'd be a 1 and 2 x's for the first guy. So that 1 is understood to be in front. I'm not going to write it because I don't have to have it. When I divide that 12 by a 3, I'm going to have minus 4. Now I took his x away, but he still has a y. And then that last term, when I divide by 6 by 3, I'd have a 2. Now he had 2 x's, but I took 1 away, so he has an x left. So here in the blue would be our factored answer. Okay. If I look at this one, again, a key here, there's 2 variables, a and b. So it's a good indicator of we're doing the GCF. So now 14, 12, and 24, the biggest number that divides them all. Well, let's see, 14 is 2 and 7, 2 and 6, 2 and... I think the biggest thing is dividing out a 2. That 14 kind of messes it up getting any higher. How many A's? He has 1 A, the middle term has 2 A's, and then the last term has a single A. So all we can take away is an A from everybody. And how many B's? The first guy's got 3, the middle guy's only has 1, and the last guy only has 1. So I can only take a B from everybody away too. Now, what's left inside? Divide. 14 divided by 2 would be a 7. The first guy, I took his A away, and I took away 1 of his B's, so he'd have B squared left. Plus, 12 divided by 2 would leave me with a 6. 2 A's, but I took 1 away, so he only has 1 now. And I took away his only B, so he doesn't have any more B's. 24 divided by 2, 12. Oh, I took his A and his B away. No good. So this is my answer here in the blue, factored. All right, I've got one more. GCF is a pretty self-explanatory concept. There's just one thing that you should be aware about, and we're going to talk about it in this example. 18 and 9. What is the greatest number that both of them share? 18 and 9. It's true that 3 divides them, but can I get bigger than 3? Oh, yeah, you can do a 9. Okay. F and 2 G's, F and a single G. Well, they both have an F and they both have a G that I could take away. So when I take away all this stuff, let's see, 18 divided by 9, he'd have a 2. Now I took his only F, but he would have a G left. Minus, holy cats! I took the 9, the F, and the G. There's nothing left. So do I just leave it, blank there? Act like there wasn't anything there? Well, not quite. Think about going to an amusement park, riding on a roller coaster, and you've waited so long in line, and then, oh, you're getting so close, but, oh, man, you have to go to the bathroom. So hopefully you have a buddy there to hold your place in line. Well, we need to be a buddy to this second term and hold his place. So to do that, we put a 1 to save his place in line. And then this would be my factored form. Okay, so hopefully you've caught on about the concept of factoring out your GCF. Have fun, guys. Keep learning, and I'll see you next time.